Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into SemiWiki's analysis of TSMC's 2 nanometers process, unveiled at IEDM 2024. It's a major advancement, folks.
Absolutely. I'm particularly interested in how it stacks up against the competition. What are the key takeaways from SemiWiki's assessment?
Well, TSMC boasted a 30% power improvement and a 15% performance boost over their 3 nanometers N3E node. They also claim it's the densest and most power-efficient 2 nanometers process out there. Early yield reports are promising too.
Impressive claims. But SemiWiki seems a bit skeptical, right? They mention a lack of concrete data in TSMC's presentation.
Exactly. The article points out that TSMC's IEDM presentation was more marketing than technical. There were no specific SRAM cell sizes, and all the performance graphs were relative, without actual units. A bit frustrating for those of us who crave hard numbers.
So how did SemiWiki actually assess the 2 nanometers process then? What methodology did they use?
They used a combination of the limited data from the paper, their own analysis, and previous node-to-node improvements from both TSMC and Samsung. They even incorporated data from Intel, where possible, to create a comprehensive comparison. They looked at power, performance, area, PPA, yield, and wafer pricing.
I see. And what were their findings regarding power efficiency? That 30% improvement sounds amazing.
Yeah, it is. But here's the kicker. They found a discrepancy. There was a power efficiency graph in an earlier version of TSMC's paper, showing a much higher improvement than the 30% claimed. It's interesting. The graph was removed from the final version, which raises some questions.
That's a significant discrepancy. What about performance and area? How did TSMC's 2 nanometers fare in those areas?
Based on their analysis, SemiWiki believes Intel's 18A process currently holds the performance crown, with TSMC in a close second and Samsung trailing. In terms of area, TSMC's 2 nanometers appears to be the densest, significantly ahead of both Intel and Samsung.
So TSMC leads in density and possibly power efficiency, but Intel takes the performance lead. Interesting. What about yield and wafer pricing? Those are crucial factors for adoption, right?
Absolutely. TSMC reported impressive yield numbers for a 256 megabit SRAM array, over 80% average and 90% peak. That's good news. However, the rumored $30,000 per wafer price is a major concern. SemiWiki believes that price is too high and could push customers towards Intel and Samsung.
That high price point could be a game changer. It seems like TSMC's 2 nanometers process is a mixed bag. Excellent density and yield, but potentially hampered by price and a slight performance deficit compared to Intel. What about backside power delivery?
That's another key area. Intel is leading the way with backside power delivery in their 18A process, expected to ramp in 2025. Samsung is following suit in 2026. TSMC, however, is lagging, not expected to implement it until 2026 at the earliest. This could be a significant advantage for Intel and Samsung, especially for high-performance computing applications.
So it seems the race to 2 nanometers is far from over. It's fascinating to see how these different strategies play out. Thanks for breaking down this complex analysis for us.
My pleasure. It's an exciting time in the semiconductor industry, and this is just one piece of the puzzle. Remember to check out the full article on SemiWiki for more detailed information. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and have a great day.
Bye-bye.